Now we'll see the Poissons ratio. Poissons ratio. The scientist Poisson was given one relation. That relation is called as a Poisson's ratio. So what that relation will see in this class. Now what we'll do here, we'll take one example. I will take here one of the rubber band which is having the thickness or diameter d, the original diameter d, and the original length of the that rubber is, I will take L. So now up to here what we have seen, we have applied a stress to the body and body is going to be change their configurations, that is called as a strain and then stress. So now in this lecture what we are going to see, if we are applying a longitudinal force, if you are applying a longitudinal stress, then what are going to be changed in the dead body? The body length is going to be changed. The body length is going to be changed, that is small l I will take. So how it is going to be changed? See here, this is the original length, and now if I applied the force to that body, the body length is going to be changed, that is called as change in length. So and now similarly what will happen in the body, however the length is increases, like that the diameter of the dead body is going to be decreases, like that the diameter of the body is going to be decreased. I think you have seen. So what to do here, you have to take a rubber and then stretch it. So see in that time before applying a stress and then next after applied the stress, so the length of the that rubber is going to be increases and then the thickness is there, the diameter is going to be decreases. So that is the procedure is there in the that body while applying the force. So now here the ratio is there, what we will take here, we are going to take the initial and then final dimensions. So the what is the Poisson's ratio here? The Poisson's ratio is nothing but the ratio of lateral strain to the longitudinal. It is indicated with the sigma, and then the ratio of lateral strain to the longitudinal strain. So the lateral strain is indicated with the beta and longitudinal strain is indicated with the alpha. So therefore sigma is equals to beta divided by alpha. So now here how you are getting this expression? So here what is the lateral strain? So the ratio of here, the ratio of change in a dimension to the initial dimension. So what is the change in dimension? The ratio of change in dimension to the original dimension, that is perpendicular to the direction of the forces. That is perpendicular to the direction of the forces, that is original dimension. So that is a perpendicular. How it is changing? It is a perpendicular to the data applied force. I am applying the force in this direction, so it is changing here in the perpendicular direction. So here now the change in the dimension, that is will take d, small d, and then original dimension, that is capital D. So therefore the lateral strain is d by d. And now similarly longitudinal strain, here also the ratio of change in dimension to the original dimension. So therefore now here we'll get that is a change in dimension, that is a length, and then original dimension is a capital L. And now here within this elastic limit, the lateral strain here in this Poissons ratio, within the elastic limit, the lateral strain is directly proportional to the longitudinal strain. So now that Poissons ratio is defined as the ratio of lateral strain to the longitudinal strain is a constant for all materials. It is a constant for all materials. It may be rubber, it may be steel, it may be copper, it may be aluminium. For any material that is going to be constant. Therefore the longitudinal Poissons ratio is equals to the beta. What is the beta? Beta is, this is the beta, and this is the alpha. So therefore now here beta is d by capital D and whole divided by small l divided by capital L. So therefore the equation becomes L divided by small l and small d divided by capital D. Therefore Poissons ratio sigma equals to L divided by D into capital D into D divided by D into L. It means it is differentiating here, or it may be this much, that is L into D divided by small l into capital D. So therefore this is the change in the diameter and change in the length.